Hello viewers, welcome back to our channel. Now today we want to deal with this radical geometry problem. So you've been told to find the semicircle area. Now in this geometry problem we have the semicircle and an inscribed trapezium. So if we take that to a whiteboard, we have a semicircle and inscribed right trapezium. So this is a right trapezium in that the slant heights are equal. So if these slant heights are equal and we have the two parallel sides, so it means from the center, a line of symmetry meeting it at 90 degrees will divide the trapezium into two parts. Now if you look at our trapezium here, the one of the parallel sides is 6 cm and the other is 12 cm. So 6 cm will be divided into 3 cm and 3 cm, 12 cm will be divided into 6 cm by 6 cm. So if we project that here, we will have this side will be divided into 3 cm and here will be 6 cm. Then this area of 36 will be divided into two equal parts, meaning this one of the side will be 18 cm square, the other side will also be 18 cm square. So the area of the green part is 18 cm square. Now if we take this length from this point up to this point to be the height h, then we know that the area of a trapezium is given by a half a plus b times h, which is giving us 18 centimeters square. Now we know one of the sides we let to be a and the other side to be b. So we have a half into a plus b, 3 plus 6, that is 3 plus 6 is 9. Then times h should be give you 18. So what do we have here? If we multiply both sides by 2, 2 goes with the 2. Then you remain with the 9h to be equals to 18 times 2 is 36. So if you divide both sides by 9, then you're supposed to get h to be 4. So it means this height from this point up to this point we found to be 4. Now let us let this other height, the smaller one down here, to be small h. Now remember, any line from the center of the circle to the circumference is the radius, meaning from O to this point is going to be the radius r. Then again from O to this point is going to be the radius r. So if we say, if maybe we let this point to be A and this point to be B and that point to be C, then if you take triangle OAB, so if you take triangle OAB, triangle OAB is a right angle triangle at point A. So when we have a right angle triangle, remember this length was 6 cm, it was divided into 3 cm and 3 cm. This length was 12 cm, it was divided into 6 cm and 6 cm. So if you take triangle OAB, that is a right angle triangle, and we can use the Pythagoras theorem. So you can see that is going to be OB squared, which is r squared to be equals to OA. From O to A is this small h plus 4. That is going to be h plus 4 squared. Then it is plus from A to B, which is 3 squared. When you use Pythagoras theorem, that is c squared is equals to a squared plus b squared. So that one is a case when we use triangle OAB, which is a right angle triangle at point A. Again, triangle O, when you let this point to be point D, so triangle ODC is also a right angle triangle at point D. So again, when you take triangle ODC, it is a right angle triangle. So the longest side is the hypotenuse C. You can let one of the sides is A and B. So what do we have? When you use Pythagoras theorem, in that case, we have from O to C is the hypotenuse. That is going to be r squared to be equals to from O to D is going to be h squared, then plus from D to C is 6 squared. Now if you look at the two equations, this equation and this equation, they are equal because both of them are r squared. So it means when you compare the two equations of r squared, we'll have h plus 4, squared, then plus 3 squared. This equation for r squared is equals to this equation for r squared, which is h squared plus 6 squared. So if you open this bracket, h plus 4 squared, that's a quadratic identity, you will get h squared, h times 4 is 4h times 2, that is plus 8h plus 4 squared is 16, then plus 3 squared is 9, will be equals to h squared plus 6 squared is 36. Now if you look at this, you can now see h squared goes on either side of the equation. So what do we remain with here? We remain with 8h to be equals to 36, positive 16 going the other side, minus 16, positive 9 going the other side, minus 9. So what do we get? So from there we now get 8h to be equals to, 8h is equals to 36 minus 16 minus 9 is 11. So if we divide both sides by 8, we end up with small h being 11 over 8. So it means from O to D is 11 over 8. Now that one makes our work simple. So we can now get r squared using any triangle. We can use triangle ODC the way we had it previously. So from triangle ODC you have r squared is from O to D, which is 11, over 8 squared, then plus from D to C is 6 squared. So what do we get to be r squared? So r squared we found is 11 over 8 squared plus 6 squared. So we have r squared is 2425 over 64. So r squared is 2425 over 64. So what do they want? They want the area of the semicircle. So having found r squared, we are now looking for the area of the semicircle. Remember, how do we get the area of a semicircle? Remember, the area of a circle is pi r squared. So if it is a semicircle, we divide by 2. So it means it is pi over 2 times r squared. And r squared we found is 2425 over 64. So if you multiply that, you're supposed to get 2425 times pi is 2425 pi over 2 times 64 is 128, and that is approximately 59.5 centimeters square. Ladies and gentlemen, that is the simplest trick to determine the area of the semicircle in this radical geometry problem. Thank you for watching, and don't forget to subscribe to our channel. See you again in our next presentation.